Hello and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight we begin a journey not through space as it is, but as it will be. Imagine a sky not as it looks tonight, but as it might appear billions of years from now. The stars still watching, the moon still glowing. But something's changing. The sun, our gentle golden companion, is quietly preparing to transform, not in a sudden blaze, but in a long, patient unfolding. So come along, lie back and picture this. You're floating above the solar system, suspended in time, watching the delicate dance of orbits, the hush of the void, and the slow breath of a star. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tap that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. The sun is steady for now. At the heart of the solar system, it glows with the kind of certainty you rarely find in the universe. A soft, brilliant ball of hydrogen and helium burning in silence. Its light touches every planet, every icy rock at the edge of its reach. But even stars age, and the sun, quiet as it seems, has already begun to change. You hover near its surface, now close enough to see its roiling layers. The granules, like golden cells, rise and fall, driven by nuclear fire beneath. The corona shimmers out into the dark, stretching farther than your eyes can follow. But beneath that surface, a transformation is brewing. The sun, like all stars, is powered by fusion. Deep in its core, atoms of hydrogen are pushed together, squeezed by immense pressure and heat until they merge. Every second, 600 million tons of hydrogen fuse into helium. That process releases energy, light, heat, and the push that keeps the sun from collapsing under its own gravity. But fusion isn't eternal. As helium builds up in the core, it changes the balance. Hydrogen gets used up, the helium core grows denser, and the sun begins to heat up more just to keep shining the same. This isn't the kind of change we feel on a summer afternoon. It's slow, deliberate, a ticking of a cosmic clock with a very long hand. But already over the past billion years, the sun has become about 10% brighter, and it will only get brighter still. Do you feel it? That subtle tension, that deep, warm breath of a star preparing for its next act. No rush. The sun still has about 5 billion years of fuel left in its core. But the story has already begun. The helium core is like a growing seed of future change. It presses inward, dense and unburning for now, but steadily affecting the structure of the star. The outer layers respond, heating, puffing out ever so slightly, adjusting. Have you ever watched someone stretch just before waking? A long, quiet reach that hints at coming motion. That's what the sun is doing. And you, little Earth, tiny Mercury, the gas giants beyond, you're all orbiting a star that is slowly, surely, stretching. You might ask yourself, will we notice, will anything seem different in our lifetimes? Or even in 100, 1,000? The answer is no, not really. But over millions of years, the changes stack. Light becomes more intense. Solar radiation creeps upward. Earth's climate begins a very long shift. Ice melts, storms change, weather patterns twist into unfamiliar shapes. And all the while the sun glows as if nothing is happening. That's the paradox of stars. They seem eternal, but they're always changing even when they look still. The sun is a creature of habit, yes, but also of destiny. And its destiny is to become something else entirely. You float backward now, leaving the bright warmth of its surface, retreating to the cold vacuum beyond. From this distance, it's just a perfect sphere, gold and white and radiant, the center of everything. But you know better now. You know the fire inside it isn't endless. And you know the first signs of something monumental are already glowing quietly in the heart of our familiar star. So we begin here with a star that is still normal, still sustaining life on a small blue planet. But we won't stay here, because this story is one of endings, and of what happens next. You linger just beyond the solar surface, suspended in the hush, where solar wind begins its journey. Here the light still glows bright and golden, but deeper inside the sun, something much hotter and far more intense is at work. The core. It's a place of unimaginable pressure, over 250 billion times the air pressure you breathe on Earth, and a temperature climbing past 15 million degrees Celsius. You can't see it directly, of course. The light that's born in the core takes tens of thousands of years to bounce its way to the surface, weaving through layer after layer of dense plasma like a photon in a crowded subway. But you can feel its intention. This is where fusion happens, where hydrogen nuclei protons are crushed together so forcefully that they overcome their natural repulsion. They merge, and when they do, a bit of mass disappears, transformed into pure energy. EYMC2 in real time, every second of every day. Have you ever wondered why the sun doesn't just collapse in on itself under its own mass, or why it doesn't explode outright? It's balance. A perfect, delicate tension between gravity pulling inward and fusion pushing outward. One wants to crush the other, wants to expand. And in that standoff, a star is born. But this balance has a clock. You might ask, what happens when the fuel starts to run low? Not all at once, not like flicking a switch, more like a candle slowly pooling wax. Hydrogen is gradually depleted in the core, though the outer layers still burn on. As hydrogen thins out, the core, made of accumulating helium ash, grows heavier, denser, and that weight pushes inward harder. The sun doesn't give in quietly. It responds the only way it knows how, by heating up more. Hotter core, faster fusion in the surrounding shell, and suddenly brighter light. The sun begins to overachieve. But even that is just a temporary trick, because helium, unlike hydrogen, doesn't fuse easily. It needs far more heat. Something the sun's current core can't quite muster yet. So instead, the helium waits. It presses inward, like a weight the star doesn't know how to lift yet. The surrounding hydrogen-burning shell is forced into overdrive, creating more energy, puffing up the sun's outer layers, even as its core contracts. You're watching a star begin to lose its balance, subtly, slowly, almost imperceptibly. From the outside, the sun will look brighter, warmer. Not alarming. But this internal tug-of-war is only getting stronger. The fusion furnace is not failing exactly, but it's adapting. And adaptation in stars doesn't mean calm. It means growth. In a billion years, the sun will be 10% more luminous than it is now. Earth will already be feeling it. Oceans will begin to evaporate. Weather systems will become unfamiliar. Even life itself will shift, evolve, or struggle in ways we can't yet imagine. And yet the sun still looks golden, still feels gentle on your skin. It's hard to picture something that seems so nurturing as a looming threat. But imagine this: inside, the sun layers are shifting, growing more unstable. Gravity and heat are pushing and pushing. The sun is slowly building toward a phase where it will no longer hold back. There's a quiet poetry, and that isn't there. A star long thought, constant, gathering the strength to transform itself completely. We often think of stars as eternal, unchanging, but they are performers, each with an arc, a beginning, a crescendo, and a finale. You're watching the middle of the show right now, and you're beginning to notice the subtle signs of what's to come. The outer layers are warming, The core is tightening. The fuel that once flowed freely is being used up grain by grain, photon by photon. And somewhere inside, a transformation is being written, one pulse at a time. You float quietly above it all, and maybe you start to wonder, is this the fate of every star? How many suns have swelled and swallowed their worlds before ours? How many more are waiting their turn? Because the sun is not unique. Its story is shared by countless stars in countless systems, each writing its own slow goodbye. But tonight you're watching our star, and it's only just begun to stretch. You drift farther out now, just beyond the orbit of Earth. The planets circle the sun like dancers, orbiting a warm fire, steady, silent, never quite touching, but always pulled by its gravity. From here, the light still seems perfect. It touches the blue of Earth, the pale haze of Venus, the rust of Mars. But in truth, this light has already changed, slowly, almost unnoticeably. Yet it's brighter than it used to be by more than 10% since Earth first formed, and that number is rising. You look back at the sun and notice how it seems to pulse more boldly than before. Not flickering, no, it's far too proud for that, but glowing with a confidence that comes from growing older and more powerful. This is a main sequence star entering its middle age, and like anyone in their prime, it's burning energy faster than it once did. But there's a cost. The brighter it burns, the faster it spends its limited store of hydrogen fuel. Right now, the sun fuses about 600 million tons of hydrogen every second, and with every passing moment, more helium piles up in the core, compressing it, making it hotter still. There's a whisper of tension you can feel, even from this distance, a star warming itself too quickly, outpacing its own design. And it's already starting to affect its planetary children. Start with Earth, that cozy blue oasis. In 1 billion years, the sun's added brightness will make Earth feel like a greenhouse slowly turning up the dial. More heat means more water vapor in the atmosphere. Water vapor is a greenhouse gas, so the planet begins to heat itself even faster in response. It's a feedback loop, soft at first, but relentless. Oceans evaporate slowly, then more quickly. Clouds become thicker, then disappear altogether. Rain falls less often, then not at all. In about 1 to 1.5 billion years, Earth's surface could become so hot that liquid water can no longer exist. Life, if it survives, will be unrecognizable. Only extremophiles, organisms that thrive in heat and radiation, might endure in cracks and crevices, clinging to shadowed rocks like memories. You wonder, would anyone still be around to notice? Would intelligent life have fled, adapted, or would Earth have long since been a planet of archives, a fossil of thought? Venus, one orbit closer to the Sun, offers a glimpse of that possible future. Its atmosphere, a hellish swirl of carbon dioxide and sulfuric acid, reminds you what runaway greenhouse effects can do. Its surface is hot enough to melt lead. Its clouds reflect sunlight away, but trap far more heat than they shed. Earth may follow a similar path, slowly, inexorably. But that's still far ahead. For now, the sun remains mostly serene, quietly growing brighter. You watch as it continues its burn, not knowing, perhaps not caring, that it's already changing the fate of everything around it. And what about Mars? So cold today, so distant. But in this warming solar system, it begins to thaw. Its polar ice caps shrink. Ancient lakes might stir again. Temperatures may climb just enough to melt water for a while. In a twist of cosmic irony, as Earth becomes less habitable, Mars becomes more inviting. If life ever spreads outward from Earth, it might make its way to the red deserts of Mars, planting seeds of thought where there were once only rocks and wind. But even that won't last forever, because the sun won't stop changing. Each year, the fusion in its shell grows more intense. The helium core becomes heavier and smaller. The balance between pressure and gravity becomes more fragile, and eventually the sun will reach a point where it can no longer hold itself in its current form. The hydrogen in the core will run out, and when it does, the transformation begins. Have you ever watched a balloon begin to expand slow and steady, filled not with air, but with fire and time? That's what happens. The sun's outer layers will begin to swell, not in a burst, but like a deep, patient breath. It will become a red giant hundreds of times its current size. But that's a story for later. Tonight, in this moment, you float quietly among planets, orbiting a star that still looks gentle, still warms, still shines, still calls to life. But deep inside, it's preparing something far more dramatic. And every planet in its orbit, Mercury, Venus, Earth, Mars, and beyond, is already dancing to the first notes of its slow crescendo. You're drifting now toward the sun's closest companion. Mercury, the tiny cratered sentinel that clings to the innermost orbit like a moth too close to the flame. It's a quiet little world, barely larger than Earth's moon, scorched on one side and frozen on the other, forever caught in a dance with the sun's light. From this vantage, Mercury feels fragile. Even now in our time, its days are extreme. Daytime temperatures soar above 430 degrees and its nights plunge to 180 degrees. It has no atmosphere to speak of, no clouds to shelter it, no winds to carry warmth or coolness across its battered surface. It simply endures. And yet it's held its place for billions of years, faithfully circling the sun every 88 Earth days. It's a fast mover, Mercury, named well after the messenger god with winged sandals. But even speed can't save it, because the sun is beginning to swell. Not now, not tomorrow, but in time it will grow to such an enormous size that its edges may stretch out past Mercury's entire orbit. Picture that for a moment. A star that once looked like a golden coin in the sky becomes a fiery wall engulfing space that was once cold and empty. Mercury has no chance. The gravitational tug from the bloated sun will begin to alter Mercury's orbit even before it touches flame. The planet will spiral inward, pulled by tides of solar gravity, like a pebble circling a drain. And once it crosses that final threshold, it will vanish, not in a dramatic explosion, but in silence. The sun's outer layers are hot, yes, but diffuse. Mercury will glide into them like a whisper into steam. Its rocky surface will melt, then vaporize, and finally dissolve into the solar envelope like sugar in warm tea. No trace, no echo, just memory. You wonder, will the sun feel that? Will it register the moment its closest companion is gone? Perhaps not. The sun has no eyes, no thoughts, no heart. And yet, it behaves as if it feeds on its planets, not out of cruelty, but inevitability. Like fire-consuming wood, it simply does what it must. Mercury's iron core, one of the densest in the solar system, will sink into the star's edge, perhaps briefly altering its internal chemistry. But even that, over time, will be forgotten. You ask yourself, if Mercury disappears, what changes? And the answer is almost nothing, except that the sun will seem just a little more alone. Its inner orbit, once vibrant with motion, becomes quiet. The solar winds no longer bend around Mercury's presence. Its long, eccentric history, its craters, its mysteries, its name become echoes in textbooks, footnotes, in cosmic memory. It makes you think, doesn't it, about how even worlds can be lost with barely a ripple. And Mercury is only the first. But it's a reminder that everything close to the sun is on borrowed time, that even the smallest planet has a role to play in the grand finale. Before you drift away, take one last look at Mercury's pitted surface. The deep grooves, The impact scars the ancient lava plains, hardened into silence. They've weathered billions of years, but they won't survive what's coming. Soon the place closest to the sun will simply be gone, and the solar system will move on, as it always has, one planet fewer, one story closed. You drift backward again, slow and reverent. One down, and so many more to follow. You're hovering now near the jewel of soft light we call Venus, a planet bathed in brightness, wrapped in clouds so thick they hide the surface from even the most curious eyes. From this height, it looks deceptively peaceful, glowing like a pearl in the sunlight, the clouds swirling gently across its yellow-white face. But beneath those clouds, Venus is already a furnace. Its surface bakes at a steady 464 digs hot enough to melt lead hotter even than Mercury, despite being farther from the sun. The reason its thick atmosphere over 90 times the pressure of Earth's traps heat in a runaway greenhouse effect. Carbon dioxide makes up nearly all of its skies, and sulfuric acid rains from the upper clouds in delicate, deadly drizzles. Venus is what happens when a planet loses control of its thermostat, and yet it wasn't always this way. Scientists believe Venus once may have had oceans, a cooler surface, perhaps even the early ingredients for life. But something changed. Perhaps it was too close to the sun. Perhaps its volcanoes overpowered its climate. Perhaps the atmosphere grew greedy for carbon. Whatever the cause, it's now a warning sign, a whisper of Earth's possible future. You float beside it now, watching the sunlight grow just a little more intense. With every passing eon, the sun's brightness increases, and Venus begins to shimmer with even greater heat. Its upper atmosphere starts to thin. The balance of its delicate, if dangerous climate begins to tip even further. Eventually, Venus too will spiral inward, not from decay, but from tidal forces, gravitational pulls, and drags caused by the expanding sun's mass distribution. The outer layers of a red giant sun will reach outward like warm fog, and Venus, no longer able to maintain its distance, will begin to drift closer. You might imagine the planet trying to resist clinging to its orbit like a child to a railing, but it's no use. The sun's pull is too persistent, too enormous. It's not a dramatic fall, more of a slide, a slow surrender. Venus, wrapped in its veil, begins to brush the outer atmosphere of the red giant. Its thick clouds scorch away. Its surface, already a hellscape, melts further. Mountains collapse into lava seas. Plateaus dissolve into steam. And then, like Mercury before it, Venus is gone. Swallowed whole, it makes no sound. The sun does not roar, it only expands. You might ask, will the sun stop here? Or is this just the beginning? The answer is written in the fusion happening deep within the core. By the time Venus meets its fate, the sun will have nearly exhausted all the hydrogen in its center. What remains is a dense core of helium shrinking under gravity and a hydrogen-burning shell wrapped around it like a scarf of fire. That shell will burn even more fiercely now, producing enough outward pressure to blow the sun's surface layers out to nearly 200 times its original radius. At its peak, the sun will become so large that it could reach well into Earth's current orbit. But Earth has its own chapter to come. For now, you watch Venus vanish beneath the folds of red-hot plasma. A planet once too hot for life becomes too non-existent for even memory. And again, the solar system shifts. 2 inner planets gone. The space between the Sun and Mars begins to feel oddly empty. And you wonder if Venus once held water, once knew softness. Was it aware of how close it came to a gentler fate? Or is this simply how stars end stories? Not with fury, but with warmth too great to bear. You drift onward. The sun is still glowing, and the next planet, your home, is waiting. Now slowly, gently, you drift towards Earth, that pale blue dot, still spinning, still breathing clouds across its oceans, still wearing the thin shimmer of atmosphere, like silk on skin. For now, from this distance, it appears unchanged. It still glows with that quiet beauty that makes hearts ache and telescopes stare. But you know better. The transformation is already underway. The sun, that familiar golden companion, is now 30% brighter than it was when life first blossomed here. The sky is still blue. The grass still grows. But the planet's climate is changing in slow, irreversible steps. You descend through Earth's upper atmosphere, where layers of ozone still swirl in their protective dance. But even here, temperature gradients have begun to shift. Solar energy hits harder now. More ultraviolet light filters through. More heat is absorbed and retained. Have you ever stood in the sun and felt its warmth deepen not suddenly, but by degrees? That's Earth's new reality. Oceans begin to evaporate. Slowly, yes, but steadily. Each century brings a higher sea level, then a broader mist, then a sky thick with humidity. Water vapor, once a cooling presence, through clouds and rain becomes a trap, a greenhouse gas that catches the sun's rays and wraps the planet in warmth. Within a billion years, Earth may reach what scientists call a moist greenhouse state. The oceans don't boil outright, but their vapor fills the atmosphere like steam in a closed room. Surface temperatures soar, tropical zones expand, the poles melt, then vanish. Eventually, the water escapes into space. Solar radiation splits water molecules apart. Hydrogen floats away too light to hold on to. Oxygen reacts with surface rocks and disappears underground. One by one, the ingredients for habitability drift out of reach. But long before Earth becomes truly uninhabitable, life will begin to feel the shift. Plants that once thrived in balanced cycles of sun and rain begin to wilt. Forests thin, deserts expand. Species migrate, adapt, or vanish. Even humans, if they're still here, will look upward and notice something wrong with the sky. The sun looks larger, hotter. Not menacing, not yet, but unfamiliar. And it's just the beginning. Because in time, the sun will grow enormous. As hydrogen runs out in the core, fusion in the shell intensifies. The outer layers begin to expand outward, slowly, like the first motion of a balloon. The sun will swell into a red giant, its diameter reaching out past Mercury and Venus toward Earth. But what happens next isn't quite so simple. Will Earth be swallowed or spared? That depends on the complex physics of mass loss. As the sun expands, it loses some of its outer material in a wind of charged particles. That reduces its overall gravity just a little, and Earth's orbit may drift outward away from danger. Some models say this might be enough to keep Earth just beyond the red giant's reach. But it's a narrow escape. Even if Earth isn't consumed, the sun will loom so large in the sky that half the heavens will be fire. The surface will bake under waves of heat. Mountains will melt. The atmosphere will strip away. Oceans long gone will be memories etched into dry sea floors. This won't be the Earth you know. Not anymore. It becomes a burnt shell, molten glowing faintly, as if embarrassed by its own ruin. You wonder if you stood on the last patch of solid ground, what would the sky look like? A horizon filled with fire. No blue, no stars, just the belly of a dying sun. And still in some quiet part of your mind you ask, could anything survive? In caves, in deep ocean crust, in engineered bubbles? Maybe for a time, but eventually heat wins, and Earth becomes still, not destroyed, not shattered, but silenced. It remains as a glowing ember drifting in a wider orbit or falling inward depending on the sun's final expansion. And just like Mercury, just like Venus, it becomes part of the star it once called its own. You rise now, slowly leaving Earth behind, still beautiful even as it fades, still home even in memory. But its chapter is nearly over, and ahead lies a cold red rock waiting for its turn beneath the swelling sky. Your gaze turns outward now, past the vanished orbit of Mercury, the ghost trail of Venus, and the smoldering echo of Earth. What lies ahead is Mars, the Red Wanderer, a planet that has long stirred our imaginations with whispers of ancient rivers, of robotic explorers, of someday being our second home. Tonight you drift gently toward it, watching as it spins beneath a rust-red haze. Its valleys stretch like ancient scars. Olympus Mons, the tallest volcano in the solar system, stands frozen in silence. The thin atmosphere hugs the surface like breath too shallow to support life. Temperatures dip as low as 125 degrees C, and dust devils twirl lazily across the plains. For now, Mars is a cold desert. But that will change, because as the sun swells toward its red giant phase, its warming embrace will reach farther, spreading its influence to realms once untouched by its most intense heat. Mars will begin to thaw, not suddenly but patiently, as if, after billions of years, the sun is finally ready to cradle its distant child. The polar ice caps, those gleaming mounds of carbon dioxide and water, will begin to recede. Subsurface ice may start to melt. Ancient channels carved by water might once again carry trickles across the dust. Temperatures will rise not to tropical levels, but enough to shift the planet's chemistry. Maybe enough to awaken long-dormant molecules. Maybe even enough for life to spark if the right ingredients are waiting. You imagine Mars beginning to bloom just a little. A hazy atmosphere, a thin mist, patches of warmth beneath red cliffs. Could it be for a brief moment in cosmic time that Mars becomes habitable? If humanity survived Earth's transformation, perhaps it would have moved here. To floating cities, underground habitats, hopes etched into Martian soil. Maybe the seeds of culture would continue here, even as Earth faded. But it wouldn't last, because the sun isn't done growing. Its outer layers will balloon until the sun spans more than one astronomical unit, the distance from Earth to the sun today. At its largest, the sun could reach 1.2 AU, enough to threaten even Mars's current orbit. And like the inner planets before it, Mars may be engulfed. Even if it escapes the sun's physical grasp, it won't avoid the heat. Surface temperatures will rise beyond water's boiling point. The delicate atmosphere will be stripped by solar wind. Radiation will sweep the surface clean of any shelter. Structures, if built, will buckle and melt. Any dream of long-term survival here dissolves in waves of solar fire. The red planet will become a red ember, perhaps a final refuge for life, if only briefly. Perhaps a tomb. It's a strange kind of kindness, this temporary reprieve. Mars lives a little longer than Earth. It is spared the first crescendo of the sun's bloom, but in the end it too is claimed. You float now above Olympus Mons, watching its shadow stretch under a reddened sky. The horizon is no longer black with stars, its crimson swollen with the light of a sun, no longer golden. And for a moment, it's breathtaking. Because even in death, Mars holds a kind of quiet dignity. It doesn't burn with drama, it simply fades. The sun, now bloated and shedding mass, grows unstable. Its outer layers ripple like a veil in slow wind. The solar system, once ordered and calm, begins to tremble. And Mars, once a hopeful exile, becomes a memory too. You drift outward again, past the reach of flame. What lies beyond the fire are worlds of gas and ice, ancient and immense. But even they are beginning to feel the shift. Because when a star like the sun changes, nothing remains untouched, not even the giants. Now you float beyond the scorch and silence of the inner planets into the cool shadows where the gas giants roam. First to greet you is Jupiter, the king of the solar system, wrapped in bands of cream caramel and crimson, forever churning with storms as old as civilizations. Jupiter is massive, more than 300 times the mass of Earth, so heavy that it doesn't orbit the sun alone, but dances with it around a shared center of gravity just outside the sun's surface. Even from here, you can see the great red spot swirling like a wound in slow motion, a storm twice the size of Earth raging for at least 350 years. The sun's heat, now stretching outward in its red giant phase, hasn't yet scorched Jupiter. Here the light is brighter than it used to be, yes, but still faint compared to the harsh brilliance near Earth. The outer solar system feels quieter, gentler. But the sun's reach doesn't stop at light. It changes everything. Jupiter's outer layers begin to warm ever so slightly, not enough to turn gas to fire, but enough to agitate the atmosphere. Storms grow more turbulent. The bands of color deepen and twist. The upper atmosphere inflates. You imagine the planet murmuring, waking from a colder slumber to find itself in an unfamiliar heat. And Jupiter's children, the Galilean moons, start to respond. There's Europa, icy and smooth, hiding a salty ocean beneath a crust of frozen stillness. With more sunlight comes a slow thawing, and you picture that underground ocean stirring just a little more. Could this extra warmth encourage life if it hasn't already begun? Then there's Ganymede, the largest moon in the solar system, even bigger than Mercury. It too may hold a subsurface sea. Its thin atmosphere thickens slightly under solar warmth. Small changes, but in cosmic terms profound. Io, ever restless, volcanically alive, becomes even more volatile. Its molten underbelly responds to the heat and gravitational flexing. You can almost hear the hiss of sulfur and steam bursting from newly cracked vents. And Callisto, ancient and cratered, distant and quiet, glimmers faintly under the new sun. Maybe it will remain unchanged, or maybe it too will stir ever so slightly. Jupiter itself will not be swallowed. It's too far, too massive, too stubborn. But it will not escape untouched. The growing sun sheds enormous amounts of mass through powerful stellar wind solar particles radiating outward like whispers of departure. This mass loss weakens the sun's gravity, and Jupiter, sensing the change, drifts outward as though politely backing away from a companion that's grown too warm. Its orbit expands. All the gas giants begin this slow migration, not a fall inward, but a retreat. The solar system stretches like a rubber band loosening under tension. And as the planets spread apart, the balance of gravitational harmony shifts. Tiny nudges in orbits lead to complex, chaotic outcomes. Moons may be ejected. Asteroids pulled from the belt might tumble toward the inner system. Comets from the Kuiper Belt, once distant and icy, may feel the new gravity and swing sunward. Jupiter's role as guardian of the solar system becomes more delicate. Its influence on asteroid paths, on orbital resonance, on cosmic balance is distorted. You wonder how many ancient systems have unraveled quietly like this. No bangs, no drama, just the gentle reweaving of orbits, of gravity of time. Still, Jupiter remains regal. Its colors swirl with new intensity. Its moons twinkle like curious children watching the sun's transformation. And though the sun's light burns brighter, Jupiter holds firm. For now. You move outward once more, the cold, returning to your imaginary skin, the stars growing clearer. Ahead lies Saturn, the ringed philosopher, and the icy borderlands, where time moves slower and light feels borrowed. But Jupiter, vast and bold, remains behind you, warming in ways subtle and strange. A king observing his changing kingdom, unsure of what comes next. You glide now toward the most poetic sight in our solar system. Saturn, the elegant drifter, wrapped in rings of ice and dust. Its golden hues shift under the changing light, a world that always seemed like it belonged in a painting more than a planetary system. Even from here, Saturn's rings are breathtaking. They stretch over 280,000 kilometers wide, yet are astonishingly thin sometimes, just 10 meters thick in places. Tiny particles of water ice and rock dance in orbit, colliding gently, glinting with borrowed sunlight. It's like watching time spin itself into spirals. But Saturn, like everything else, is starting to feel the sun's transformation. Even from this distance, over 1.4 billion kilometers away, the growing red giant now casts a brighter, redder light than it ever has. The gentle glow that once painted Saturn in whispers now arrives in warmer, more intrusive rays. Its upper atmosphere, once frigid, begins to warm. Temperatures on Saturn typically hover around 140 degrees Celsius, but even a slight rise stirs new atmospheric currents. The planet's stripes of pale yellow, tan, and gray begin to roil more actively. Clouds grow taller, and storm systems like the famed hexagonal jet stream at its north pole intensify as if reacting to the heat, like muscles twitching in surprise. Saturn is no stranger to drama. Enormous storms erupt here every few decades, stretching thousands of kilometers. But under the sun's expanding gaze, even Saturn's slow rhythms are disrupted. The deep hydrogen-helium atmosphere bulges ever so slightly, like it's exhaling. But what about the rings? Ah, yes, you watch them now, icy, sharp-edged, beautiful. And they're disappearing, not dramatically, but steadily. Even now, Saturn's rings are fading, not because of solar heat, but because of a gentle process scientists call ring rain. The tiny particles that make up the rings are slowly falling into Saturn's atmosphere, pulled down by gravity and guided by magnetic fields like silver snowflakes on an invisible wind. Estimates suggest the rings could vanish in less than 100 million years. And as the sun grows brighter, radiation pressure increases, pushing more ring material inward. The particles collide, more often, lose energy, and spiral down. One day, perhaps sooner than you'd expect, the majestic rings will be gone, and Saturn will be left bare. You picture it Saturn without its crown, just another gas giant. Still beautiful, but somehow less iconic. But Saturn has more than rings. It has a family. And those moons, those lovely varied moons, each begin to tell their own story as the sun's warmth reaches farther than ever before. There's Titan, the largest of them all, swaddled in a thick orange atmosphere, richer than Earth's, filled with nitrogen and methane. Lakes and rivers of liquid methane wind across its frozen surface. But now, with rising temperatures, that methane begins to evaporate, creating storms and clouds the likes of which have never been seen. Could this be a second Earth in waiting? It's an idea scientists have long pondered. With the right heat, Titan might host a methane cycle, akin to Earth's water cycle. Perhaps in these distant eons, the sun's warmth could briefly make Titan habitable, not for humans, but for life built on different chemistry. There's Enceladus, smaller, brighter, and colder, one of the most reflective bodies in the solar system. It too holds a subsurface, ocean venting watery plumes into space like sighs through cracks in its icy shell. As temperatures rise, those cracks widen, more plumes erupt. Perhaps briefly that ocean churns with new energy. Saturn's other moons, Dione, Rhea, Iapetus, each respond in their own way. Ice melts, orbits shift. Tidal forces grow stronger. The sun has become a giver of warmth to the outer solar system, even as it takes it from the inner. But don't mistake this for peace. The warmth is temporary. The expansion is chaotic. The balance is fragile. And Saturn, lovely Saturn, knows this. Its orbit is drifting outward now, along with all the other giants. The sun, losing mass with every solar wind, tugs less strongly on the strings of its system. Saturn recedes, but you get the feeling it watches everything as it goes: the vanished Earth, the fading rings, the moons warming in surprise. It's a witness to a solar system's slow unraveling. You linger one moment longer, letting your gaze trace the shimmering curve of what remains of the rings, the flicker of Titan's cloud tops, the ghost silver glow of Enceladus. And then, as the sun's redness deepens behind you, you drift farther still, toward the blue edge of cold, where Uranus and Neptune spin in quiet exile. Now you drift into the deeper twilight, the outermost dominion of the sun's planetary reach. The light here is soft, slow, almost reverent, like candlelight through stained glass. And in that distant hush, you come upon the ice giants. First Uranus, then Neptune. Cold, massive, and mysterious, these worlds have always existed just out of easy reach, whispering secrets through telescopes. Uranus floats before you, now tilted on its side, like it's lounging, not orbiting. Its 98-degree axial tilt means it rolls rather than spins, and each of its poles takes turns basking in long, dim seasons that last over 40 years each. Its color is serene, a pale cyan haze, smooth and understated compared to the stormy drama of Jupiter or Saturn. But don't be fooled by appearances. Beneath that pastel exterior lies a world of exotic chemistry and quiet violence. Temperatures on Uranus can plummet to 224 degrees Celsius, making it the coldest planet in the solar system. But even here in this frozen cradle, the red giant sun is beginning to extend its influence. The solar light that once barely warmed Uranus now glows with unusual strength. Not hot, not yet, but bright enough to nudge the atmosphere into motion. Cloud bands that once drifted silently may begin to stir. Perhaps methane ice in the upper layers begins to sublimate, rising into gassy form under this newfound attention. You wonder, what does it feel like for a world that has only known darkness to finally bask in warmth? Does it sigh, shimmer, begin to dance? Uranus's moons, there are 27 of them, begin to thaw as well. Tiny worlds with names like Ariel, Umbriel, Titania, and Oberon, drawn from Shakespeare and Pope, each icy and sculpted like forgotten sculptures. Some of them might hide water beneath their crusts, some might wake. And beyond Uranus lies Neptune, the windiest planet, spinning with speeds of over 2,000 km/h. Its color is deeper, a royal blue that seems to absorb the sky. From here, the sun looks like a swollen red ember, but its light is stronger than Neptune has ever known. Even here, Neptune's atmosphere begins to change. The dark storms deepen, the winds shift. The ice-cold clouds rearrange into more complex shapes, reacting to heat that's never touched them before. Neptune's largest moon, Triton, is especially intriguing. It orbits backwards in retrograde, likely a captured object from the Kuiper Belt. It has geysers of nitrogen that erupt from below its surface, like breath through a sleeping mouth. With just a little more warmth, those eruptions become more frequent, more dramatic. The ice may soften, cracks widen. Activity stirs in the shadow. These ice giants won't be swallowed by the sun. They're simply too far. But they too drift outward, their orbits stretching as the sun's mass slowly melts away into space. The solar system becomes less tightly wound, more like a dancer spinning slower and wider after releasing her grip. And in this gentle creeping chaos, some moons may break free. Others may collide. The gravitational waltz that held them steady begins to falter. Everything shifts. You take a final look at Uranus spinning softly on its side, like a marble lost in a snowdrift. Then Neptune deep brooding and royal turning beneath that endless wind. They are the watchers now. They do not fall, but they remember. And beyond them, beyond even their furthest moon, shadows lies the frosty edge of the solar system, the Kuiper Belt, and Oort cloud, where comets sleep and darkness reigns. You drift outward past Neptune's whisper into this icy silence where the sun is little more than a memory, yet still holds power. What lies ahead isn't a planet, but a threshold, a place where the solar system begins to unravel. And you still dreaming continue on. You float now beyond the last great planets, beyond Neptune's deep blue storms and Uranus's sleepy spin. Ahead lies the vast outer veil of the solar system, a kingdom of silence called the Kuiper Belt. Here the light from the red giant sun is soft and reddish, more like the glow of embers than the fire of day. It's no longer bright enough to cast shadows. Instead, it gently outlines icy shapes drifting in the dark. And the first to greet you is Pluto. Yes, still here, still cold, still proud, still tracing its eccentric orbit that sometimes brings it closer to the sun than Neptune. Pluto doesn't care about its status. It hums with dignity, cloaked in nitrogen ice, wearing a heart-shaped glacier like a secret love letter. But even here the sun's transformation is felt. The surface, once locked in perpetual frost, now begins to soften. Temperatures rise not enough to melt, but enough to stir. Gases trapped beneath the crust begin to seep out. The tenuous atmosphere thickens slightly, forming a delicate veil of nitrogen, methane, and carbon monoxide. You imagine standing on Pluto now, staring up at a red sun. It's larger than you'd ever seen it. From Earth, perhaps 10 times bigger in the sky, a crimson giant hovering like a balloon above the horizon. And with that warmth, a strange sort of spring arrives. Cryovolcanoes, volcanoes that erupt, icy slurries, may awaken releasing ammonia and water from deep within. Pluto's crust expands and contracts, cracking like old paint. Subsurface oceans long theorized might stir beneath layers of insulating rock and ice. Is it possible, you wonder, that life could emerge here? Not life as we know it, but something slower, stranger, built on ice chemistry and deep cold. Maybe not life in bloom, but life in pause stirred by warmth. Past Pluto lies a community of other Kuiper Belt objects, Make, Haumea, Eris, and 1,000 unnamed others. These frozen dwarfs, some smaller than cities, some rivaling Pluto in size, begin to experience similar awakenings. Haumea, shaped like a stretched football, starts to flex and spin as heat seeps in. Eris, almost a twin to Pluto in mass, develops a hazy atmosphere. Even tiny rocks no bigger than mountains begin to shift in silence. The Kuiper Belt was always thought of as a place of stillness, but now it's becoming restless. And farther still, much farther, is the Oort cloud, a spherical shell of icy debris, so distant that it marks the border between our solar system and the stars beyond. This is the domain of comets. Billions of them. Some are small, just dusty snowballs. Others are enormous ancient time capsules from the very birth of the sun. They've slept here for billions of years, orbiting so far away, it takes millions of years to complete a single loop. But now, with the sun growing hotter and lighter, the gentle pull that once held them in place begins to loosen. Some are flung away, cast into interstellar space. Others drift inward, pulled by complex gravity dances or nudged by passing stars. And those that fall toward the red giant sun will leave trails of light comet tails blooming like ghostly banners through the sky. The solar system becomes a place of motion. Again, not because of formation, but because of unraveling. You pause in the Oort cloud so far out that the sun is just a flickering dot, brighter than other stars, but hardly familiar. The Milky Way arcs behind you, like spilled sugar in the dark. And still, the sun speaks. Its mass loss continues, turning even this distant realm into a shifting sea of debris. Some of these icy bodies will never return. Others may be caught in the gravity of new systems adopted by alien stars, orphaned into other lives. The solar system you knew is expanding. Its reach is widening, but its grip is weakening. You're not just watching a planetary system anymore. You're watching a star let go of its children, and they drift into the dark, silent and shining. The light of the sun, once golden and warm, and cradling the worlds in its embrace, is now a bloated ember of its former self, red, swollen, and unstable. You float just past the boundary of the Oort cloud, and behind you the solar system is no longer the tidy clockwork of orbits and icy predictability. It is a drifting symphony, slowing, expanding, forgetting. The red giant sun is nearing the final movement of its life. Inside that swollen star, fusion has grown desperate. Hydrogen, its primary fuel, is long gone from the core. Instead, helium fuses into carbon and oxygen, creating immense pressure and temperature. The outer layers pulse and swell as if the sun itself is breathing in slow panic. This is not a quiet process. It's a chaotic shedding of mass, a last attempt to hold on to balance before everything gives way. And those outer layers, they begin to peel away, not in a single explosion, but in waves, like layers of clothing discarded one by one. Over time, those waves build a shell of shimmering gas around the dying star. You imagine them now rippling outward, like the petals of a cosmic flower. This glowing shell becomes what astronomers call a planetary nebula, not because it has anything to do with planets, but because the first astronomers who saw them through telescopes thought they looked like distant orbs. You watch the beginning of this process now. The sun's outer layers, once the source of gentle warmth, begin to glow faintly blue at the edges. The gases swirl in radiant loops. The colors are surreal soft purples, pale greens, faded oranges, mixing like watercolor in space. From the outside, it's beautiful. From the inside, it's chaos. The solar wind strengthens. The corona flares violently. Magnetic loops arc and twist into storms large enough to engulf Earth 10 times over if Earth were still there. All the while, the core shrinks. It condenses under its own weight, becoming impossibly dense. It can no longer fuse helium, but it still glows brilliantly hot, nearly 100,000 degrees Kelvin, though no longer expanding. It becomes what we know as a white dwarf, a stellar ghost. About the size of Earth, but with the mass of the sun, this tiny ember will glow for trillions of years, slowly fading into cold darkness. But for now it is blindingly bright, the exposed heart of a star suspended in the glowing cocoon of the nebula it created. You picture it now, the white dwarf in the center, and around it, a sphere of light, not unlike the delicate patterns of soap bubbles or jellyfish glowing gently in the dark. This is the end of the sun's metamorphosis. From birth in a nursery of gas, to fusion-fueled youth, to a swelling elder of planetary consumption, to this, an ancient spark adrift in memory. And around it the solar system is unrecognizable. No inner planets remain. The gas giants drift far, their moons colder and farther than ever. The Kuiper Belt is thinned, the Oort cloud is leaking, and the stars of neighboring systems now shine just as brightly as what used to be the heart of it all. Yet somehow, the solar system still persists, not as it was, but as a relic, a remnant. Perhaps somewhere a probe continues its silent journey. Perhaps Voyager launched centuries before. All this still sails outward, its golden record intact, hoping to whisper stories of the sun to anyone who listens. And perhaps a lone moon, icy, cratered, forgotten circles. A planet that once circled a star, its orbit now wide and strange but stable. Everything is different, everything is slower, but nothing is truly gone. The atoms that once made up Earth, the elements forged in the sun's belly. Carbon, nitrogen, oxygen, they're drifting outward, now woven into the nebula. Eventually, those atoms may seed new stars, new planets, new stories. Maybe someday someone or something will breathe that stardust and dream again. And you, quiet Voyager, watch it all with reverent stillness. This is not an ending. It's a return. The sun, having given all it could, becomes a monument to time, glowing quietly in its last act. You float there weightless and calm as space holds its breath. And the white dwarf shines. Now you float on the slow tide of time, watching the planetary nebula unfurl like a final exhale. The solar system, once a place of movement and orchestration, has become a quiet archive, a shelled-out museum of past warmth and symmetry. The white dwarf glows at the center. Its light is fierce but fading, a spark in the silence, surrounded by tendrils of color that stretch across space. This nebula won't last long, cosmically speaking. Perhaps 10,000 to 20,000 years, and then it will dissipate, dissolve into the interstellar medium, where it will mix with other stardust and memory. You wonder how the outer planets carry on. Saturn, Jupiter, Uranus, and Neptune, they've all drifted much farther out now. With the sun losing about half its mass during its red giant phase, their orbits expanded drastically. Each of them is now 1.5 times or more their original distance from the sun. That slow outward slide continues as the white dwarf's gravity weakens over trillions of years. But some planets might not stay tethered forever. The system's balance, once precise, has been disrupted. Even small gravitational nudges from a passing star, a rogue planet, or the tiny pull of a neighboring moon could send the outer world spiraling outward or even eject them into interstellar space. They would become rogue planets, castaways in the galactic sea, sailing without a sun. And yet for now, they linger. Imagine Jupiter, now a grand faded sphere, turning under a distant spark of white. Its storms still swirl, but slower, gentler. The great red spot may have calmed to a pale rose, no longer driven by heat from within or from above. Its many moons continue to orbit it, tiny worlds tracing loops in the cold. Saturn's rings may be gone, but Titan with its thick atmosphere might remain interesting. Some theorize that as long as internal warmth persists, perhaps from radioactive decay, its subsurface ocean could still exist, sealed beneath layers of methane ice and crust. And what about Uranus and Neptune? Still spinning, still distant, perhaps too far now to feel even a whisper of heat. But internally they hold secrets, pressures, and chemistry that continue regardless of their star's fate. If any moons had subsurface oceans or hydrothermal activity, those may last for billions more years. It is a solar system in deep retirement. No more photosynthesis, no more weather cycles, no more sunrises, just inertia, just memory. And all around in every direction lies the interstellar medium, a thin fog of gas and dust where future stars will one day be born. And in that fog, the ingredients from the solar system are already mixing in. Calcium from the sun's core, carbon from Earth's breath, iron from ancient meteorites, water from comets, and perhaps something more. Perhaps the molecules of life, amino acids, proteins, sugars, travel outward with the wind. Perhaps a tiny microbe long dormant, frozen in a chunk of rock, drifts for 1 billion years before being pulled into the gravity well of a new young star system. Imagine that. Imagine Earth's story being read again, somewhere else. You drift now, not just through space, but through legacy. The solar system is becoming one of many buried threads in the great cosmic tapestry. The sun's light, once sharp and clear, now rests in the soft hands of history. And even the white dwarf will not last. Eventually, after trillions of years, it will cool into a black dwarf, a cold, dark cinder of a star. The universe may not have lasted long enough yet for any black dwarfs to exist, but in time, they will. Silent relics of suns, no longer glowing, no longer burning, just waiting. You wonder if somewhere out there another sleepy star will awaken. Will its planets thrive? Will it harbor curious life, the kind that looks up and wonders what came before? Will it someday launch a telescope and catch the faint outline of a planetary nebula? A ring of color, a white-hot point, a whisper of what we once were. You continue drifting in that quiet reverie, letting the calm pull you forward. The sun's story is nearly finished, but the universe moves on. Time becomes syrupy now, thick, slow, immeasurable. You float through the remains of a solar system whose central fire has all but dimmed. The planets are shadows of their former selves, the sun no longer a source of life, but a glowing fossil suspended in black velvet. And yet, the story is not entirely over, because even in the silence of cosmic dusk, things still move. Gravity still whispers, atoms still shiver, and the sun, now a white dwarf, still spins quietly at the heart of what was once a warm, bright family. This dwarf is tiny, about the size of Earth, but so dense that a teaspoon of its material would weigh as much as a skyscraper. It's a sphere of carbon and oxygen, glowing with leftover heat. No fusion burns within it anymore. It's only shedding its warmth molecule by molecule, like a fire dying under layers of ash. You hover near it. There are no sunspots, no solar flares. Its surface is smooth, pale, and hard, and coldness, slow and certain, creeps across it over billions and then trillions of years. But what is it like for the universe to wait that long? What does it mean for a world to linger in near absolute zero while galaxies dance and collide, stars are born and die, and black holes slowly consume what remains? Ask yourself what happens to a world after time forgets it. And here's where something marvelous happens. Because although the sun's planets have drifted far, and many may have escaped entirely into the galaxy beyond, some may remain still faintly circling, like loyal ghosts orbiting a pale flame. They no longer receive energy from the sun, but internal processes continue very, very slowly. Jupiter's massive core still radiates a bit of heat left over from its formation. Titan may still carry a frozen ocean beneath its crust, wrapped tight in darkness. And in places untouched for eons, quantum events flicker at the edge of perception, subatomic particles appearing and vanishing like fireflies in fog. It's tempting to think nothing is happening. But even now, the clock of the universe ticks onward. The white dwarf continues to cool. Perhaps it crystallizes from the inside out. Yes, astronomers believe white dwarfs may eventually become enormous diamonds. In space, their carbon cores frozen into lattice structures under impossible pressure. A literal gem, a star-shaped diamond floating alone. What stories would that diamond carry? Would it remember Mercury's boiling rock, Earth's breath and music? Mars's wind-blown dust? Would it hum with echoes of sunlit oceans and laughing atmospheres? And beyond it all, the Milky Way itself begins to change. Stars collide, black holes merge. Eventually, gravitational encounters may disrupt the orbits of remaining stars, flinging some into intergalactic space. Even white dwarfs like the Sun may be ejected, becoming solitary travelers through the black. The Sun may leave its place, entirely abandoning the coordinates we once thought permanent, drifting alone through the void for eternity. No planets, no moons, just a diamond-white ember coasting in silence. But there's something strangely beautiful about this vision. The Sun was always giving of light, of warmth, of gravity and shelter. And even in its final state, it's still a beacon of quiet resilience. It still holds form. It still exists. And you are witnessing it, not in sadness, but in awe. Because this is how stars say goodbye, not with explosions, but with endurance. You imagine the galaxy's core, its arms slowly curling and loosening as entropy wins its long game. But here in this tiny place, where one star once ruled, a small light still glows. It does not move fast, it does not flare, but it is honest and steady and eternal for as long as matter itself can last. And that is how the Sun's long goodbye becomes not an ending, but a lullaby. One last light rocking softly in the cradle of space. You linger now in the final hush of the solar story. The last breath of warmth from the white dwarf fades slowly, gently, never in haste. No longer a flame, not yet a memory. It is simply quiet. You drift alongside it, and the silence is not empty. It is full with all the moments that came before. The golden childhood of the sun, the swirling dance of planets, the birth and death of moons, tides, storms, and songs. And now a kind of stillness that feels earned. As the white dwarf cools, it becomes transparent to time. It emits no more visible light. It no longer shapes orbits with force. But it still exists, enduring in a way that feels almost spiritual. The cosmos does not mourn it. Instead, it carries it forward, woven into the galactic breeze. You imagine now, 1,000,000,000 years from this moment, that the white dwarf has finally cooled into a black dwarf, a cold, lightless relic. No longer a star, but a ghost of one. A mass of carbon and oxygen so stable that it may outlast everything else. Black dwarfs are theoretical. The universe simply hasn't been around long enough to create one yet. But the sun one day will become one of the first. Its final form will not glow. It will not orbit. It will simply be a cosmic keepsake holding inside it the timeline of everything that orbited it once. If you could crack it open like an old book, you might read whispers of Earth's atmosphere. Mars's red storms, Venus's veil, the magnetic dance of Jupiter, the strange sideways serenity of Uranus, Neptune's endless blue wind. They're all inside somehow, condensed, preserved. You wonder, lying still beside it, what the far, far future might bring. Will spacefaring civilizations from other galaxies come across this dark gem and study its density, its crystallized core? Will they ask who made this, who orbited here, who dreamed beneath this light? And perhaps they'll find fragments, an ancient probe still blinking, a microscopic fossil tucked into an icy rock, a poem etched into gold and flung toward the stars. Perhaps they'll find us. And perhaps they'll know from this tiny ember that there once was a people who looked up and wondered what happens in the end. Now you drift just beyond the black dwarf. The solar system is no longer a system. It is a dispersal. Atoms once gathered into planets are now dust between stars. Moons are scattered, lost, repurposed by gravity's long fingers. And yet, from this remnant, one truth remains. Everything that ever lived, loved, or learned under the sun was made possible by its fire. It burned just right. It gave just enough, and though it asked for nothing in return, It has now been returned to everything. You let go of the last glimmer, watching it fade behind you as the universe stretches on. And just before darkness takes full hold, you sense a softness, a ripple, almost like a yawn spreading across the sky. The stars remain, and they wait for new stories to begin. And now we rest. Let your breath slow with the vast, quiet rhythm of deep space. Let your body relax into the stillness between stars. You've traveled far tonight, not just through space, but through time, through billions of years, across light years of emptiness, and into the tender heart of a star's long farewell. The sun has given us everything: light, warmth, life. Even the elements that make you lying there now, peaceful and calm. From the calcium in your bones to the iron in your blood, you carry a story written in solar fire. And just as the planets drift quietly now, you too can surrender to gravity, to stillness, to sleep. Ooh, let the last image be soft and slow, a dark jewel cold and ancient, floating in the quiet ocean of the galaxy. It holds no heat, no color, but it holds memory. And somewhere in that memory is the imprint of Earth, of oceans and trees and laughter and wonder, of you. Let that bring comfort. Let it bring peace. Because in the end, even stars rest, and so now should you. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening, from what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night, sweet dreams.